Okay, I think we're rolling here. So the other way to do this, so I just took this one and rewrote it. Cosine x, sine x, cosine x. Let's get all the terms on one side. And so instead of dividing by cosine x, we'll subtract it. Now, it's not a like term, so you can't subtract it from this cosine. This is its own thing, so it's just say separate. Now at this point here, we're gonna factor out the greatest common factor, which is cosine, and you can think of it as undistributing cosine. That would look like this. Cosine is the greatest common factor, and if we factor it out from the first term, the leftover is sine. You can think of it like we're dividing it out of this one and using that instead as representing as multiplication outside the parenthesis. Same for this one. Divide this by cosine. Factor out a cosine from cosine, and the leftover is minus 1. Now, if we take this factor, if that's equal to 0, then and since it's multiplying, the whole thing will be equal to 0 and it'll be true. And so let's solve this one. Sine x equals 1. And we discussed this on the previous method here. There are two answers, pi over 2 or 5 pi over 2. Okay, and then in this case, cosine x, if this is equal to 0, then the whole thing will be equal to 0. And cosine is the x value, and so I'll circle here. Where the x value, the x coordinate, so this x is an angle, but where the x coordinate system is equal to 0 would be right here and right here. So pi over 2, which also works over here, so it's redundant answer. And then down here, this would be in between pi and 2 pi is 3 pi over 2. Okay, so that would be pi over 2, 3 pi over 2. And then this answer, which would be one time around, that would be 2 pi plus pi over 2, which we discussed earlier was 5 pi over 2. So that's also redundant as these answers over here. So the three answers here are pi over 2, 3 pi over 2, and 5 pi over 2 are all potential answers that if we went back to the original problem right here and we plug those in, it would make it true.